But let's go through this example where it's relatively easy to calculate the area just by our normal area formulas. So the first thing they want us to do here is identify the vertices. So a vertex is each of the edges of the shape, each of the points on the graph. So A is 1, 4. B is 3, 6. C is 6, 3. And D is 4, 1. Great. Now they want us to find the perimeter using the distance formula. So hopefully we remember what the distance formula is, but if you don't, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So first off, this is a rectangle, so we don't have to find the lengths of every single side. We can just find the lengths of one short side and one of the long sides. So let's find the distance between A and B. So again, this is for between A and B. So distance is equal to so this up here is our x1, y1, and this is our x2, y2. So we want to subtract the x points first, so 3 minus 1 squared plus y2 minus y1 squared So 3 minus 1 is 2 squared. 6 minus 4 is also 2 squared. And so that equals the square root of 4 plus 4. And so our distance between point A and point B is the square root of 8. So this distance right here is the square root of 8. We know that this is a rectangle because it tells us here in the problem. So this side is the square root of 8, as is this side. Now, we want to find the distance of one of the longer sides, so let's choose between A and D. So this is between A and D. And again, we're going to use this formula right here. Except now we have a different x2. So I'm going to erase our labels over our B because we're not using point B anymore. We are using point D. So now this is our x2 and this is our y2. So in our first parentheses, we have x2 minus x1. So that's 4 minus 1 squared plus 1 minus 4 squared. So 4 minus 1 is 3, so that's 3 squared, plus 1 minus 4 is negative 3, so negative 3 squared. So D is equal to 9 plus 9, the square root of 9 plus 9. So that is equal to the square root of 18. So that means that the distance between point A and point D is the square root of 18. And because this is a rectangle, that means that this distance between B and C is also the square root of 18. Now, let's calculate the area of this rectangle using the distances that we just calculated. So the area of a rectangle is length times width. Our length is the square root of 18 times the square root of 8. And if we put that into our calculators, we will find that that is equal to 12 units, and this is area, and so our units are squared. And also, they wanted us to find the perimeter using the distance formula up here. So we have to add up all of these numbers to get the perimeter. So P is equal to the square root of 8 plus the square root of 8 plus the square root of 18 plus the square root of 18. And when we add up all of those numbers, we should get we should get 14.14 units. All right. So we just calculated the perimeter using the distance formula, and we used those calculations to find our area. Now, let's, for the first time, introduce this shoelace method. So to do the shoelace method, the first thing you have to do is list all of your vertices, starting with A and moving counterclockwise. It is important that you put them in the right order, as we will see later. So our first point is A, and A is 1, 4. Our next point moving counterclockwise is D. So D is 4, 1. C is 6, 4. And B is 3, 6. And now for the shoelace formula. So the way you figure out what your shoelace formula is going to be is you're going to take your points and you're going to label them with x1, x and y1. And you're going to do this for all of the points. So you have a total of 4 points. You're eventually going to have x4 and y4. So going in order, this is x1 and y1. This is x2 and y2. This is x3 and this is y3. All right. So the first part of the shoelace formula, you write out your x1 and y1, and you're going to do this for all of your points. So x2, y2, x3, y3, x4, and y4. Now, in this first column that you make, you are going to extend the y column by 1 and repeat y1. And then you're going to circle, make circles on your point like this. And you should start to see why it's called the shoelace method. It kind of looks like shoelaces. All right, before I explain what to do with these, let's make the second column. So you're going to repeat this step by writing out your x1, y1, and do this for all of your points we have up through x4. So x2, y2, x3, y3, x4, and y4. Except on this side, now you're going to repeat your x value. So x1 is the last one in this column. And we're going to draw circles going diagonally, just like we did on the other side, but make it mirrored. All right, so the way this formula works is you're going to take all of the circles on this side, and you're going to add them together. And inside each circle, these values will be multiplied. And then all the circles on this side, they're going to be subtracted. So let's see what that looks like in the actual formula. And be aware that this is a monster of a formula. But once you understand how it is made, it should be easy to come up with. So we're going to start with what we add first. So these two values get multiplied together. So x1, y2, and then again, all of these are going to be added together. So this is x1, y2 plus x2 times y3 plus x3 times y4 plus x4 times y1. And then all of these circles are going to be subtracted. So now we start using subtraction signs. So our first value in here is y1 times x2. So y1 x2 subtract y2 x3 subtract y3 x4 subtract y4 x1. And that's the end of it. And again, this looks like a monster of a formula, but as long as you have your points up here labeled with the correct labels, you should be able to match them into the formula and easily calculate. So I'm going to put all of my products here in parentheses just so it's a little bit easier to read. So x1 is 1, and we're going to multiply that by y2, which is also 1. And we're going to add that to y2, which is 1, times x2, which is 4, times y3, which is also 4. And we're going to add that to x3, which is 6, times y4, which is also 6, plus x4, which is 3, times y1, which is 4. And we're going to subtract y1, which is 4, times x2, which is also 4. And then we subtract y2, which is 1, times x3, which is 6. And then we're going to subtract y3, which is 4, times x4, which is 3. And then we're going to subtract y4, which is 6, times x1, which is 1. And whew, that was a long process, but that's it. So now let's do the math within these parentheses. So 1 times 1 is 1, plus 4 times 4 is 16, plus 6 times 6 is 36, plus 3 times 4 is 12, minus 4 times 4 is 16, minus 1 times 6 is 6, minus 4 times 3 is 12, minus 6 times 1 is 6. All right, so you can either use mental math to figure this out, or you can just put it into your calculator, but either way, when you do, you should get the area to be 12 units squared. And notice that this came out to be the exact same as what we found when we used the distance formula, which it should.